Hi, this is CNC demonstration and something to learn about it. Okay, first to see how it works, turn on power supply. I need to go to the manual mode and to turn on hand wheel, and you see the x-axis is blinking, so that means that I can change the x-axis on the CNC control. And when I took a hand wheel, this wire doesn't get me, the motor is going to rotate. I can rotate 1 ticks for the 1 micrometer. This is a millimeter, so this is 1 micrometer. I can put it on time 10 with this knob to time 10, so I can change for 20 micrometers, and that's going to, of course, rotate motor faster for more angles, for more rotations, whatever you want to call that unit of angle. And of course I can put it on the 100. When I change the 10th for the millimeter, 100 microns, it's going to make a lot of rotations. Okay, can go wide, it's going to rotate more. Now, how it works? At first, we have a hand wheel which give the pulses, give the signaling to the cable to the CNC control. And this is a cheap Chinese CNC control. Okay, it's quite good because it's industrial grade, it's robust, it can be industrial grade, it's not usual PC, and it's going to change position for some amount, and CNC control is going to send the signal to the servo control. How that looks like, let's just move the camera a little. Okay, there is a port back on the back of the CNC control to which signal is sent to the microcontroller. First, because it is RS422, it's going to through the converter to TTL 5 volt logic. It is 5 volt RS422, but it's differential, so it needs to be converted to TTL and then goes to the microcontroller. Then microcontroller know that CNC want to move the motor for some amount of ticks. 1 tick is like 1 phase of this motor. It's going to be eventually some amount of the millimeters on the CNC, and microcontroller then send the signals, pulses for to this flat cable to the motor driver. Okay, this is a power cord of the motor driver. A motor driver is going to make 3-phase signal which go to the motor. It has some resistors, so it can limit current, but now they are shorted with these crocodile cables. Okay, to limit some current, but not quite needed. Okay, and motor is going to move because it's going to get that signals. By the way, the signaling for now control is for now trapezoid. These signalings in these power cables which move the motor are trapezoid, which is the simplest method for driving the motor. Of course, it could be vector, which is going to be kind of sines, 3-phase sine for control, but that's much more complicated. Anyway, this cable is from the encoder sensor. It's a Hall sensor. It has 3-wire Hall sensor which tell us in which position is currently shaft. So it go back to the microcontroller, and microcontroller by that information can know did the motor came into the position which he instructed, microcontroller instructed to the motor. When it can send the next signaling to the motor driver to change, to move a little more, and that is the loop for the control. Now, which is kind of bad with this control is that when I try something like this, let's say like this, to move a lot the motor, and when I go for the measure to stop it, it doesn't stop. Even if it is emergency stop in the CNC control, it doesn't stop because alarm doesn't stop because there is no alarm signal for now on this prototype to stop it. Okay, but it's going to be, that would be very bad for the CNC because this machine should immediately stop any motion of the CNC, and that is going to save the lives. Anyway, I didn't explain the power supply. Power supply, it has a 5 volt for the servo, and it has a 20 volt for the motor driver, which is the biggest amount of power for driving the motor. It needs at least 20 volts because MOSFETs in the drivers are driven with the 15 volts. It has a power supply with drop to the 15 volts, so it needs at least 20 volts. And it, how you see, it consumes something about 350-60 milliamps. It consumes a little less when it is moved. Okay. Anyway, interesting effect. When I turn off this power supply, turn on, the monitor go back. It resets. What is that? This is kind of gratis lecture. It doesn't have anything in CNC, but that is electromagnetic interference. Okay, electromagnetic interference, it's a bad thing because sharp transient in this power supply, when I turn it off, it make other device to, for example, restart, which is bad. That shouldn't happen because it can block things. And for example, you can imagine what would happen that, I don't know, some device for life sustaining a patient goes off because something, I don't know, medical nurse turn on microwave oven to make a breakfast or something like that. So it shouldn't happen. And why it happened? Because these power supplies are probably, and this monitor too, are bad designed. And because that there is electromagnetic compatibility test to check every device, electrical device, does it make some electromagnetic interference, or is it resistant to electromagnetic interference? Anyway, that is everything that I can show you on this demo, at least. What is about this project is that idea is to take some old CNC machine. Currently I work on the Okuma 20, if anybody knows what machine is that. and the idea is that we could change electronics in that Okuma. It's old machine from the 80s, but it has a very old electronics, and electronics could work, but we don't have a paper tape. This machine, they didn't have a USB flash in that time. They have a paper tape. We don't have paper tape with the operating system of that controller, so we can render it useless. So we need some kind of control, and we're going to pull out old computer or controller of that machine and put this new controller, but we need to make some adaptations to their drivers, motor drivers, encoders and something like that, and this came this board. Okay, and this is 2-axis CNC latte control, which is quite cheap, and for that a quite small amount of money you can take that old CNC machine, retrofit it with new control, and have it working with a modern USB and RS 232 DNC and things like that. Why that is important? But it's important because people don't have the money to buy a new CNC machine, which could cost tens of hundreds of thousands of dollars, euros, whatever money you like, and with this you can take an old machine which is going to be thrown away on the dumpster. You can retrofit it and have it working pretty nice, because that machine anyway, Okuma is LC20, it's quite a good machine. It's quite precise and good manufacturing in machining sense, but electronic is old. That's the problem, but it could work, could do the job, and if we make it, we can spare a lot of money, have machine to work, and if God give us that blessings, we're going to, I don't know, maybe employ some people to work on that CNC machine, which would be quite cool. And that is why we are doing this project. Okay, that's everything about this machine. So to the next time, bye.